Geometric solids, we are looking at a sphere today. So, our objective for today is we are going to find the surface area of a sphere and we are going to find the volume of a sphere. Notice there's no lateral area for the sphere because the lateral area of a sphere is the same thing as the surface area. There's no base on a sphere, it's just going to be a big circular ball. Kind of think of it like this. I've got myself my nice little, this is a little bath soap here, but it's a little Pokeball bath soap. And so that's going to be a sphere. There's no base, there's nothing for it to sit on. It's just going to be all circular all the way around. So, definition of a sphere is to be the locus of points in space that are a fixed distance from a point called the sphere. It's just a really big fancy term for there's going to be a point and it's going to be all of the points that are the same distance away from that. And that's going to create the sphere. Think of it like a basketball, baseball, any sort of spherical shape or round shape there like that. That's going to be a sphere. So, surface area. First thing that we're going to look at here is surface area. Now, the nice thing about these formulas is that they really only need one thing. They only need the radius. And so in this case here, all we have to do, 4 times pi times radius squared, we just have to find the radius. Well, this right here, it's giving us the radius. It's 5 centimeters. And so since we already have that radius, we just need to plug that on in to our formula. Now, just real quick, I could also, like, if I wanted to, I could have given you one where it came through here, and I could have given you the diameter. And so if I gave you that the diameter was, say, 10 centimeters, all you'd have to do to find the radius is just diameter divided by 2. That's going to give me my radius. So 10 divided by 2 would just give me 5. So you can always do that if you're given the diameter. All right, so the radius we said is 5 centimeters. And now we're just going to plug it into our equation. So it's 4 times pi times radius squared. And so when we do that, we get 4 pi times 5 squared. Now, since I'm using pi here, I could keep this in terms of pi. And so if I do that, it's just going to be 4 times 5 squared. And when I do that, 4 times 25 is just going to give me 100. So this would be 100 pi, and then that's centimeters squared. That would be if I wanted it in terms of pi. If I wanted it as a decimal, all I do is just plug that into my calculator, and I get 314 point, we'll say 2. We'll just round it, and that's going to be square centimeters. So 314.2 square centimeters. That's going to be my surface area. Now my volume is, again, I just need pi on that, or excuse me, I just need radius. It's not very difficult to do this. The big thing that you've got to do, once you find your radius, so my radius is just 5 centimeters, you're going to plug it into the equation. I put this little note on here. Don't forget that your radius is cubed. So cubed, remember, cubed means you're taking something to the third power. So all of our volumes are in cubic meters. This here is going to be one of the reasons why, because we have the radius and we're going to do it cubed. On the other one, we're multiplying our 3 dimensions. Well, in this case here, we've got our 3 dimensions is the radius. And so that's why we're going to cube this. So we've got 4/3 times pi times radius cubed. And so when you plug that information in, we get 4/3 times pi times 5 cubed. And so we can do that. Now, if I go ahead and I want to keep this in terms of pi, I could definitely do that. I just do 4/3 times 25. And so I would get 33.33 repeating, and then that's times pi, and then that would be cubic centimeters. That would be keeping it in terms of pi. If I didn't want it in terms of pi, I just plug 33.33 pi into my calculator, and when I do that, it comes out to be 523.6, and then that is going to be cubic centimeters. And that's the volume of a sphere.